Hello everyone and welcome to another Fusion 360 Live. My name is Brad Tallis from Autodesk. On the keyboards I have my friend Angelo answering the questions. We're going to continue today through using the miter saw stand that we've been working on. As you can see here, we are going to be working on this leg assembly, specifically the whole leg. If I kind of zoom up in here, you'll see that we've got some hardware. We've got, it's kind of hard to see, but we've got a pin that goes through here with a spring, etc. And then we're also going to work on this slot. The last live stream that we did on this series, we created this sheet metal part, but we left out this slot. So we're going to show you some cool tips and tricks on how to do that. Like on my other live streams, I include the outline that I use, and I also included the drawing set. That way you can download those. They're in the description of the video. Feel free to download those after the live stream and work through this project. And feel free to share your images and stuff like that out on the Fusion 360 Facebook group. I always get a kick out of seeing what people are working on. I'm going to give a shout out to Steve Sneed. He posted where he's at with this project, so congrats Steve and thanks for sharing. Okay, so let's dive in. So we're gonna basically be creating one of the legs, and then obviously we're gonna reuse that leg around the rest of the design. So I'm gonna start out by creating a new component. I've shown in the past you can come into the assemble menu and say new component. You can click on this little icon and say new component. But my favorite thing to do is to right mouse click in my structure browser where I want that component to be. So I want it to be underneath this table assembly. So I'm going to right click and say new component. And you can't really see what's going on, but this parent says one selected. So it knows that the table assembly is going to be the parent. And this component is going to go underneath that. So I'm just going to call it leg. Pretty unoriginal. Okay. We'll create a sketch. Now, in this design, I'm actually kind of creating things out in space and then positioning them into the correct location later. So I just created a new sketch on the top plane. I'll create a circle out here somewhere. Doesn't really matter where. And let's just do 45 millimeters. Again, this is according to the drawing. So you'll see this is the drawing set. I have an exploded view. We're going to be creating this foot down here also today. And then I have a drawing of each of these. So you can see here, I forgot to dimension the diameter, so I'll fix that. I apologize. That's funny. And then we're going to do this pin that you see, this lock pin, and then we're also going to do this little foot. That's what we're going to be working on today. Okay, so it's a 45 millimeter diameter. Then I'm just going to extrude this. And I've shown this tip before. I could say finish sketch, but if I just click on my profile and right mouse click, I'm going to do this first extrude. The second extrude is a surface extrude, so you typically don't want to do that. So I'm going to do this first extrude, and you'll notice it finishes my sketch for me. So I don't have to click on finish sketch and then click on extrude. And we'll go minus 820 millimeters according to the drawing. Now, we recently added this thin extrude, which I really like. So instead of having to shell this part out or create multiple circles in my profile, I can come in here and say, I want to do a thin extrude, and it's going to ask for the wall thickness. And in this case, we're going to do 2 millimeters. And when I say OK, it's like it shelled it out for me automatically. And I didn't have to select the top face and the bottom face if I had used the shell command, for example. So cool little tip. Okay, the next thing I want to do, let's jump back to this leg, is I want to create these circles. And man, I realize I must not have finished this drawing. I didn't even dimension where they're supposed to be. Wow, I apologize. So I will dimension that and re-upload that drawing. So apologize. It's been kind of a hectic week. So I will re-upload a new drawing set in the description of the video. So maybe wait a little bit before you download that. Maybe give me a couple hours after it uploads, and you'll get some dimension drawings that actually make sense. Okay, so I'm going to create those two holes. So I'm going to use the hole command. I really like the hole command, and here's why. You'll notice I'm not even going to create a sketch, and it's asking for a placement. And if I get near the front of this, I'm going to click off to the side just a little bit. You'll notice that it actually puts it tangential to that front plane. So you can kind of see right there. Okay. Now if I were to have clicked off to the side a little bit more, so if I were to click over here, you'll see it's going to go tangential 90 degrees from that direction. So I don't even have to create like an offset plane or anything like that. It just does it automatically, which I think is pretty cool. Okay, so I'm going to just click somewhere on that face. The diameter of this top hole is going to be 11 millimeters. Okay, and then I'm going to reference this top face, and you'll notice as I hover over it, it kind of highlights. So I'm going to go ahead and click on that, and it throws a dimension there. So it's basically saying the center of this hole is going to be this distance from that top face. Well, I want it to be 15 millimeters, so I'll type in 15, and you'll see that that updates and moves that hole to be 15 millimeters from that top face. The other thing I want to do is make sure, instead of a distance, I'm going to just say go through all. In fact, I don't know if you saw that change ever so slightly. Yeah, so notice when distance was set, it wants to do an angled, let me kind of look at it from the side, it wants to do an angled drill. And it just picked some random distance or whatever. But if I came in and said go through all, you'll see that it's going to go all the way through. The drill point really doesn't matter in this case. And I'll go ahead and say OK. Okay, I'm going to create the other hole. So that was the 11 millimeter diameter hole. Now I'm going to do this 12 diameter and 6.2 diameter hole, all with the same command. So I'm going to just right click and drag straight up to repeat my last command. So if I right mouse click, you'll see this black line. That's called a gesture. And if I just right click and drag up, it's going to repeat the last command, which in this case was the hole command. If it was an extrude, it would repeat the extrude command, or a circle command, whatever your last command was. So that's how I did that. Okay, so I'm going to click on this face again somewhere. I'll reference that top face, and this needs to be 71 millimeters down, so we can see that preview. Now, what I want to do is I want to have a larger hole in the front and a smaller hole in the back for this little spring pin to go through. So I could do this with two separate hole commands, or I could change to this counter bore, and this will allow me to give a diameter here and a diameter here. So for the through hole, I want that to be 6.2 millimeters, and you can see how the preview kind of updated. That got smaller, and let me go here. So this one is going to be 12, so that was actually correct. And then for the depth, I just need to make sure I'm going deep enough that it's cutting through the wall. So you can see right here it's set to 5. I mean, I could set it to anything, really. It doesn't really matter. I just want to make sure that it's cutting through that wall. And once again, I'm going to say go through all. That way it goes all the way through. It kind of rotates funny because that's such a long part. But now you can see we're going to have a larger hole here and a smaller hole through the back. So I'm going to go ahead and say OK, and there we go. Okay, Okay, so AL asked a question. Can you ask Brad to show what does the rotation handle on that hole do? So the question was if I were to create a hole here, so you can see, it's kind of hard. It's kind of buried in here right now, but this actually allows you to, by default, it starts at that tangential face or 0 degrees of angularity. I could come in here and rotate it to whatever I want. In fact, I could come in here and say I want that to be at 45 degrees. Oops, sorry, that was the wrong one. Sorry, 45 degrees right here. So yeah, great question. Hey, y'all, thanks for doing that. Okay, moving forward. So I now kind of have the pipe the way it's supposed to look. But in the actual pipe, there is an insert that the bolt goes through. So I'm going to create a new component under the leg. Now, you'll notice here we created this leg under the table assembly. You're going to notice I'm going to create some stuff under the leg because it's kind of like all together. So I'm going to right-click here, New Component, and I'm going to call this bolt support, and I now have a new component underneath the leg called bolt support. And this will just kind of help with organization. So what I want to do is I basically want to create an insert, a circular insert that's going to go right here. Now I don't have a flat face that I could create a sketch on or anything like that. So here's a neat tip for this. I'm going to create a plane at an angle. Well, I don't want the plane on the outside here. I kind of want it through the center of my pipe. So I'm going to do an axis through a cylinder, cone, or torus. So what's the face? I'm just going to click on this face and you'll see that it created an axis that goes right down through the center of that pipe. I'll go ahead and say OK. Now you'll notice my axis is kind of long, and just like with a construction plane, if you get near the end, you can actually drag these points and make that axis line whatever length you want it to be. Okay. Then I'll come in and say I want to create a plane at an angle. Now you'll notice that I'm just going to go ahead and click on this axis, and it's going to put a excuse me, a plane through that angle, or through that axis point. Excuse me. I can also, just like in the hole command, I could come in here and rotate this and put this plane at any angle that I want. But in this case, I'm going to leave it default to 0. And just like the axis line, I could grab the corners of these, because I really don't need the plane to be gigantic or whatever. So now I have a plane that slices through the center of that pipe. Okay, now I can create a sketch. We'll go ahead and zoom up on this sketch. And I want to project, so P for project. And I want to project this cylinder. You'll notice, I could come and click on these edges, but you'll notice how it's kind of like split in half, for example. But if I hover over the cylinder, it's going to grab everything, including this hole down here and this hole down here. I'll say OK, and it's going to project that geometry for me. Okay, now I can use this to create a circle. However, you'll notice that a center point doesn't show up because this isn't really a true circle. It's on a curved surface. But you'll see these blue snap guides appear. So you can see it found one for the horizontal. Now if I just hover over this point, it's now going to find one for the vertical. And you'll see if I get kind of near the center, it's now going to snap to that one and to this one. And I now know that's my center point. So kind of a neat little tip there using snap guides. Okay, and I want to make this a 12 diameter circle. And I'll finish my sketch. Now I'm going to extrude both of these features here, profiles I should say. And I'm going to say extrude. I like to start to drag to kind of see what that's going to look like. And instead of a distance, we're going to say to object. And I'm going to click on that face, and you can see that it's going to extrude to that curved inside face. And that's kind of the key right there. I also want it to be hollow because there's a bolt that's going to go through it. So I'm going to make this a thin extrude. And we'll do a 0.5 for the wall thickness. Now, I showed this last time. I can't, well, let's try it. Let's do a symmetric. Yeah, you'll notice with symmetric, it says distance and all, and so it won't follow that shape, right? It's just basically going in the same distance both directions. So I can't do symmetric. Let's try two sides. Now this one does say distance, to object, and all. So let's try the to object, and I'll just click on that face, and that wrapped around. And then let's change this guy to object, and I'll click on that face, and you'll notice it doesn't really know which side. So this is the reason that I do the method that I do, which is a little bit more steps, 2 more steps. But I'm going to come in here and just say one side, to object. We do the wall thickness is supposed to be, I'll set that again, 0.5. I'll say OK. And I now get this little insert, and you can see that it's going to fit perfectly. It's lined up perfectly, and this actually gets welded into place. And I think it was Ekram made a comment in one of the previous videos. How would you weld that? In my example, it was the nut on top of one of the pipes or whatever. I'm actually not going to do that in the CAD system. When we get to the drawing set, we're actually going to use welding symbols, and we're going to tell the manufacturer that this needs to be welded. So instead of me creating a bead around here, I mean, I could, but there's no need to, because the drawing is going to define how this thing is going to get manufactured. Okay, so to get the other side of this, now I'm just going to click on this face and say extrude. And instead of distance, I'll say to object. And you'll see that it will extrude to the other side. And it's all one piece because we're joining it together. So yes, it's a 2-step extrude to get that piece made, but it'll follow this shape. Now, there's multiple different ways we could do this. I could have done it a long extrude and then used the pipe to subtract that out, but then I'd have to remove the extra parts that were created. But there are different methods that you could create this exact same part. So I'm not saying the way I'm doing it is the perfect way or the exact way. It's just one of the ways. Okay. Moving on here. So we now have that bolt support done. The next thing I want to do is create the pin that's going to kind of go through here. I'm calling it the lock pin because it's going to lock the leg into place through this hole right that you see right here. So once again, I'll right click on table assembly, and I'm going to create a new component. Now you'll notice I'm putting it under table assembly instead of under the leg, and I'm doing this on purpose because we're going to kind of reorganize some stuff, and I want to show you, you know, I get the question a lot, like, what happens if I put it in the wrong spot? And so I'm just showing you, I can put it here. I'll say new component. Let's call this lock pin. And you'll see it created a new component called lock pin. And it's a pretty simple shape. If I zoom out here and go to the lock pin, so it kind of looks like a cylinder and another cylinder with a little groove cut into it. That's what the final thing is going to look like. Now you'll notice on this radius, I call out this tangency weight of 2. We're going to see that here in just a minute. And then here's a detail of this little area right here. So we're going to be creating this part called the lock pin. So I'm going to start with simple shapes. I could create a sketch, but instead I'm going to just use a cylinder primitive because that's kind of the shape that it is. So I'm going to say cylinder. And I'm just going to maybe pick this front plane because it's kind of in the correct orientation. So I'll click on this front plane here. I'm just going to draw it out in space somewhere. And let's make this 11.9 in diameter and 10 millimeters in height. So you can see right there 11.9 by 10. I'll say OK. And now I'm going to create the smaller part of it. So once again, I can come over here to cylinder, or right click and drag straight up, and it's going to repeat the cylinder command for me. So I'll pick there, and the diameter for this is 6, and the height I can drag to visually see what that's going to look like. I can come in here and type in 45 for the height. So that's kind of the basic shape, and this is all one body, right? I created one because the other one was touching it, it joined it together. We can see that right here. I could have created a sketch, I could have drawn a side profile, done a revolve, totally could have done that. Could have drawn a sketch, did an extrude, create another sketch, do another extrude, totally could have done that. Multiple different ways of doing this, but I think the primitives are pretty fast. Okay, so the next thing I want to do is create that fillet on the end, and this is pretty cool. So I'm going to right click on that edge and say fillet, and I'm just going to do a standard fillet. So let's think it's 3.5 according to the drawing, and you'll see that it rounds over that edge. But you'll also see right here we have this tangency weight. And watch what happens when I type in 2. Okay? It's a little bit flatter, and then it starts to do the fillet. Let's go back to 1 so you can kind of see what it originally looked like. So it's more of a curve. So this tangency weight allows you to control how soon this fillet really happens. So there's 1.5, there's 2. So you can kind of see as I'm going through here the differences that I'm going to get. Let's try like 0.5 for example, and you can kind of see how it starts to curve really, really fast versus 1, we get a nice transition and a nice transition. So that's what this tangency weight does for you. So I'm going to make it 2, and it kind of makes the front of it a little bit flatter, but it still has a curved edge on it. Okay, now I want to create this groove. And some of you might be like, well, okay, you could do a revolve. We draw like a rectangular profile and revolve that around. Again, multiple different ways of doing this. What I'm going to do is I'm going to create a sketch on this face. Draw a circle, so C for circle. And I'm going to draw that inside diameter. So let me... Oh, I didn't even put that in my... Here we go. I'm going to put that... Actually, you know what? I lied. I'm going to back up a little bit. I'm going to put this part in the correct location first, and then I'm going to do that groove. And I'll show you why here in a little bit. It really doesn't matter, but I think it's more visual to see where it's going to go. So created the fillet on there. Now I'm going to position it where I want this to go. Now pay close attention here because you're going to see some interesting tips and tricks on how I could position this guy. So I'm going to come in here and say joint. Now, which one do I want to move? This part. And where do I want to move it to? That's how I remember. I want to move it to this part over here. But this is like a curved surface. That's going to be a little bit difficult. Well, I kind of want the middle of this head to be kind of in the middle of the hole right here. So check this out. I'm going to hover over the cylindrical face, And you'll notice it gives me a start, a middle, and an end. In fact, if I kind of look at it from the side, it'll kind of make more sense. It's kind of hard to see, but there's my start, there's my middle, and there's the end. Okay, so I'm going to grab this middle. So I just grab the middle of this cylinder right here. Then I'm going to kind of zoom up on this hole, and you'll notice as I get near this edge, this is not where I want the pin to be. None of these locations are correct. But if I hover over the circular face, you'll notice it has a start, a middle, and an end. So you can kind of think of this as like the outside edge, like right here. You can kind of think of this one as kind of like that inside edge. And you can kind of think of this middle one as right in the middle. So I'm going to click there. And what it did is it brought the middle of this cylinder into the middle of that hole. And it's perfectly centered. Hopefully that makes sense. I'm just kind of showing those joint origins. It really gives you a lot of control where you can say, go from the center of something to the center of something else. So if you need to, rewatch that part of the video. Pretty powerful. Now I'm going to change this into a slider because this pin kind of pushes into the pipe. I'll go ahead and say OK. And I now have that pin where I want it to be. And here's kind of why I decided to wait to do the groove afterwards, so you can kind of see what that's going to look like. Okay, the next thing we're going to do is now create that sketch. So my lock pin is still my active component. I'll create a sketch. We'll do a small circle here, so 4 millimeters in diameter. And then I'm going to say I'm done. Now you're like, well, that profile's on the wrong face. It's in the wrong location. Well, check this out. I'm going to grab that profile. I'll say extrude. And if I start to go like this, sure enough, it's going to use that profile and it's going to cut that geometry away. But I want it to start in a different location. And that's where this start is right here. So I'll change that from profile plane to offset. And now I can specify the offset, which is 1.5 millimeters. And now you can see it's taking this profile, it's moving 1.5 millimeters, and then it's doing the extrude cut. And in this case, it needs to be minus 0.6 in thickness. So hopefully you can kind of see what I did there. I left the profile on this face, and then we just told the extrude to start in a different location and then extrude the correct depth. And once again, I find this a little bit easier than having to create an axis, then I'd have to create a plane through that axis, then I'd have to draw a rectangle, dimension it the correct location, and then revolve, cut around. And that would take more steps than just one. Well, more like two, I should say. The profile and the extrude, basically 2 steps. Again, multiple different ways of doing this, but I like this method. Okay, so I now have my pin. We've got this little groove for a C-clip to kind of hold this thing into place. I want to put a washer on here. So I'm going to, let's see. Want to make sure I'm going to put I'm going to activate my leg assembly. Okay. Then I'm going to insert a McMaster car component. So instead of me drawing a washer or whatever, I'm going to let McMaster car do the work for me. So in the outline and in the drawing, I have the part number. So you could come in here and go to washers and then, filter through all of this, but I like to type in the number, the master car number. So I'm going to just do 986 89 alpha and then 115. And when I search for that, you're going to see it's actually going to find that for me automatically. So we can see, in fact, if I scroll up, it's a metric general purpose washer. It's a metric 6. You can kind of see it right here, stainless steel, blah, blah, blah. So by searching for that number, it brought me right here, and I can click on product detail. I want the CAD file. I'm going to do a 3D step file, so I'll just say download. And it's going to bring that into my 000 location, my origin, which is kind of far away from where it needs to be. So I like to kind of position it sort of where it needs to be. Now, it doesn't have to be exact. It's just kind of in the general area. So I'll go ahead and say OK. And then I'm going to create a joint. So I'll say joint. And you'll notice it says some components have been moved. Capture the current position or continue in the previous. So if I said continue, it would actually move it back to that 000 point. So I'm going to capture the position here, and it captured where it was, and now I'm creating a joint. So I'll say maybe like this edge or this edge, it really doesn't matter. And then once again, I'm going to grab the edge of this circle, but you'll notice that that would give me a wrong result. I need this little joint origin to be up and down. So let's turn off the lock pin and let's hover over this face, and now we can see, sure enough, there's the front edge of this hole. So I'm going to click there, and you'll see that it's going to bring the washer. Now it remembers my last motion type was a slider, so I'm going to say rigid, and we can see that that washer is now perfectly flush and centered with that hole, because I grabbed that outside origin point of the hole along this edge. Hopefully that makes sense. Okay, I'll turn the pin back on. So we now have this little washer. The next thing I want to do is bring in that little C clip. So same thing, I'll insert a McMaster car component. Okay. And I'm just going to search for the part number, and in this case it's 9917 8 alpha 101. Okay. And sure enough, it found this. I'll scroll back up so you can kind of see this external retaining ring. I mean, think about how much time that would take for me to model that, to draw that, but it already exists out here, and it's the right size. I'm just going to go ahead and click on that. I'm going to say download. Now I'm going to show you a neat little tip. Remember last time I said it brought it in at 000, and I kind of positioned it sort of close to where it needs to go. Okay, but then I said okay. Notice in here there's a capture position. So I could just click on that and say okay, and now it's not going to complain at me when I go to do the joint command. You'll notice it didn't say, you know, parts have been moved, you want to capture or continue. So you can save a step by clicking on that capture position when you insert the McMaster car component. Now I want this to be on that little, in that little groove right there. Oh, fast zoom. So I'm going to hover over like this circular, you can kind of see there's like a circular shape right here. So I could grab any of these edges, it really doesn't matter, and you can see it's going to create that little origin, that little plus symbol like right there. So I'm going to click on that, and it captured the center of that. And then I'm going to either click on like that edge there, that edge there, it doesn't really matter, honestly. And then it's going to position that clip. Now, as I look at this, it doesn't look all that great. But I can click on this flip, and you'll see that it's going to flip from being on the wrong side to being on the right side. And to answer Eyal's question about the rotate, you can see the clip is kind of like that. Well, I could now that it's in place, I could come in here and I could rotate this to any direction that I want to make it a little bit more random or something like that. Now, I usually keep them kind of orthographic, so like when I'm doing a drawing or something like that, it makes a little bit more sense, less hidden lines or something like that. But again, it's totally up to you. For example, if you were to insert a bolt with the bolt head, you could rotate that bolt head around so they're not all pointing in the exact same direction to add a little bit of realism. So, okay, so we'll go ahead and put that clip like so. Now the last thing we want to do is there's actually a spring in here that's trapped by the inside of the pipe, and what this allows us to do is we push this little pin in and it's going to allow us to rotate the leg around. So we need to create a spring. Now I could grab one from McMaster-Carr and bring it in. I could totally do that, but I wanted to show you this coil command. So in fact, I'm going to turn the let's turn the leg body off and the bolt support. Let's just turn those off to kind of simplify things. I'm going to say create coil. Now before I do that, it's going to be a part, right? So I want to make a new component. So I'm going to right click on leg, new component, and let's just call it spring. Now we're in the spring component, and anything I do will get captured in that component. So I'll say coil, and it says select a plane or planar face. So I'm going to click on this face right here. Then it says place a center point. And you'll notice that it's actually catching to the center. Let me kind of make it a little bit more isometric. It's catching to the center of this, this face right here. Okay. Now it's asking for a diameter of the spring. So I'm going to type in 6.2. And you'll notice it gives me just a little bit of clearance, and I'm going to hit enter. Okay. And it gives me a preview of what this is going to look like. Let me go try and do default here. Usually it'll look something like this or something like that. I think it's like 2 or 3 coils or whatever. And you'll notice that these coils are kind of intersecting with this pin. Well, the coil command has a lot of options in here. I'm not going to spend too much time, but you can see revolution and height. So how many revolutions and how tall is the spring? I can go revolution and pitch, height and pitch, or I can do a 2-dimensional spiral. Okay, I'm going to leave it revolution and height. How many revolutions? Well, I want it to be, in this case, let's do about 10 revolutions. And you'll notice I get an error message, failed to build. Well, that's because of the height. In fact, watch what happens when I start to drag. As soon as it can get 10 coils in there, it will. But they can't be overlapping, so if we get to, our height isn't tall enough, they would overlap, they would intersect. That's not good. So if you ever get that error message, just keep filling out stuff. So I'm going to say 38 in this case. And there we go. And then you'll notice it says section is circular. We could do square. You can do different shapes, but obviously in this case I'm going to do circular. And then this section position, it says on center. Well, I'm going to say outside. So it's going to put the coil so it wraps around this diameter right here, the 6.2 diameter. Or I could come in here and say on the inside, and it's going to be on the inside. You can kind of, oops, too far. Hello. You can kind of see how it's following this blue circle. It's on the inside of that blue circle. It's on the center of that blue circle, or it's on the outside of that blue circle. And that's what I want. So 10 revolutions, height of 38. I'll go ahead and say OK. Now the drawback with this is we started it on this face, and so you can see that it's kind of self-intersecting, that point right there. So I'm going to right click on the spring and just say move, And let's just move it, let's translate it to the right. And so you can see we can slide it along this pin. Let's just move it to the right, maybe about 1 millimeter or so. Let's just see if that looks good. Yep, that gives me some clearance there. Gives me some clearance there. I could even do maybe like 1.5. Nope, too far. So whatever works, 1.2, 1, I don't care. And let's go ahead and capture that position. Okay, so zoom back out. Let's turn our bodies back on. We now have this leg with the pin, the spring, the washer, and the clip that's going to kind of hold all of that together. Okay. I apologize. I do have a hard stop at the top of the hour. We might not get all the way through the outline. If not, we'll continue on in my next live stream. Or you can try going through the outline and following along and see how far you get. But we might not get all the way through, and I can't go over today like I usually do. So, okay. So now I kind of have all of these parts. This is what I would call kind of like a sub-assembly. But you'll see I've got like the lock pin is separate from the spring, which is up here, and the washer and the clip are up here. That doesn't make a lot of sense. And again, I was trying to simulate what might happen in the real world for you. So we're going to create, under the table assembly, I'm going to create a new component, and I'm going to call it pin assembly. There it is. And now I'm going to drag the lock pin, the spring, and these two washers and clips into my pin assembly. So I'm just grabbing those, and you can see this little blue kind of bar appear every once in a while. Well, I'm going to drop it on top of pin assembly. And now we can see that this is all one component, or I should say a sub-assembly, not one component. It's an assembly with all of our stuff inside of here. So here's my lock pin, here's my spring, here's the clip, and there's the washer. So it's a really cool way to kind of organize how things should be together, kind of like sub-assemblies, sub-sub-assemblies, etc. In fact, I'm going to create another assembly. So I'm going to say new component. Let's call it leg assembly. There it is. I'm going to put the pin assembly in there. I'm going to put the bolt support in there. And I'm going to put the leg in there. And now we can see under the leg, if I turn that on or off, you can see everything turns on and off. There's my pin assembly, which you can kind of see like a sub-assembly of it. And then there's that bolt support part, and then there's the actual leg itself. So kind of a cool way of organizing things. So the last thing I want to do on here is create that foot. So I'm going to right mouse click on my leg assembly and say foot. I now created a new component called foot. And pretty repetitive here, so I'm going to kind of go at a pretty good pace. I'm going to draw it kind of on this top view. Again, using dimensions from the drawing. So this is 40.5. I'm sorry, I lied. 45. And it's going to be 20 tall. So we're now looking at the foot. So here's the 40.5 by 20 tall. That's what we're doing there. I'm going to do the same thing. This is going to be, I'm sorry, we did the 45 by 20. Now I'm going to do the 40.5 by 27. Okay, so I will zoom up. We'll repeat my cylinder. This is the 40.5 by 27. Okay, so there's kind of the basic shape of the foot. Then I'm going to I want to create these angles here. And so I'm going to use a chamfer, and you can see it says 15 by 20 degrees and 2 by 75 degrees. So how do we do that? Well, I'm going to click on this edge, say chamfer, and by default it's set to equal distance. And so it's going to be basically a 45 degree chamfer. But if I go under this type, I can say two distances, or I can say distance and angle. So on this bottom one, it's supposed to be 15, but the angle, instead of 45, I want it to be shallower, so I'm going to say 20, and you can see how that is now 15 by 20. And then this is cool. I can add another selection to this, so I'm going to click on that plus. I'll click this top edge, and it knows that it needs to be a distance and an angle, so we'll do, again, according to the drawing, 2. So you can kind of see the preview what that looks like. But it needs to be steeper, so I'm going to say 75. I'll say OK. And we now have one chamfer feature in the timeline that's actually doing two different size chamfers. I'll fillet these bottom edges. Those are supposed to be 2 millimeters. And this top edge is supposed to be 1 millimeter. So again, just like in the chamfer, I could come in here and say add a new selection. Let's do that guy, and let's make him 1. So you can see we've got two edges at 2, one edge at 1, and the fillets that kind of define the shape of this part are under one fillet feature. So, okay. The next thing I want to do is, you can kind of see here, it's got these support ribs on the inside, and it's shelled out. So let's shell this guy out first. So I'm going to click on that top face and say shell. As I start to drag, we can kind of see a preview of what that's going to look like. It's basically shelling out the inside of the part, and the wall thickness is supposed to be 3.5 according to the drawing. So I'll say 3.5, say OK. Now I want to create those cross member things. So I'm going to zoom up a little bit. There's a flat face right here. I'm going to create a sketch. And then I want to project. P for project. I want to project that flat face right there. And the reason for that is we're going to use the web command, and all the web needs are a couple lines. So I'm going to just draw a couple lines like so. I'll do a line like this, like so. I can see that those are, horizontal and 90 degrees with each other. Well, I want these points to be touching that edge. So here's a neat little tip. I could come in here and say coincident, click that point and click that edge, and you'll see that sure enough it jumped over there. And so now that line is coincident with that edge. Well, instead of actually having to do the constraint, I can actually just grab the point, get it near that edge, and you can see like a little X show up, and it's going to create that coincident constraint for me automatically. So as you see, as I'm dragging, those points are staying touching that edge. So if you're comfortable with this, you can just drag these across, and it knows that those are now coincident points. And then the last thing is I want to make sure that they go through this point right here, that line there and that point right there. We can see that they turn black, means that they're constrained. I'll finish my sketch. And those lines are perfectly going through the center, and they're touching that edge. Then I can come in and use the web command. Really powerful command. What are the profiles? I'm going to say that guy. You can see we can change the thickness here. I'll add that edge in there also. And you can see how it's going to actually, it's kind of hard to see, but you can see it's wrapping down underneath that taper right there. It's pretty amazing how this works. Okay, and those are 5 millimeters thick. We'll say okay. And we've just created this internal support for the foot. So the next thing I want to do is there's all these little tiny ribs on the outside, and this basically allows it, when it gets pushed into the leg or the pipe, it kind of creates tension on that and holds it in place. So I need to create a profile, and we're going to use the emboss command, but I need to have a sketch to draw on. And I like to have it kind of near the part. So I'm going to come in here and say offset plane. And I'm going to pick one of these flat faces. It really doesn't matter which one, honestly. I'm just going to pick this guy. And I'm just going to drag this plane so it's sitting in front of the foot. Again, I don't really care what this distance is. I could come in and say make it exactly 30 millimeters if you wanted to, but you honestly don't have to. So I now have a plane I can create a sketch on. And again, because my foot is active, all of my features in the timeline are underneath this foot. Let's project that face there, because that's where the sketch is really going to go. So I just projected that face. You can see these purple lines. Then I'm going to create a rectangle. And I'm going to use center rectangle. And what this allows me to do is, as I get near this line and get kind of near the center, you can see it snap automatically to the midpoint. So I'm going to click there, and you can see that it's going to create a rectangle. And I want to catch down here also, but I want to be very specific in the width. So I'm going to tab to the width and type in 6. Then I'll hit tab again, and we've locked in that width. So no matter where I move my cursor, we can see that that width is locked in. Now all I need to do is come down, and you'll see it snap to that bottom edge, make it coincident with that bottom edge, and I'm actually done. Now, you might be saying, well, that rectangle is way too tall. You only need it to go right through here. And yes, that's correct. But by using the center rectangle, it was much faster. I know it's perfectly lined up. I didn't have to add a whole bunch of dimensions. And you'll notice there's my profile right there. It's because it's being split by that line right there. I don't even care about that profile. So we'll come in here, we'll say emboss. What's my sketch profile? That guy. What's my face? That one there. By default, it's usually a little bit thicker, like so. You can kind of see the preview there. According to the drawing, the depth is 0.2. So I'm going to say 0.2 and say OK. So we just embossed, so it follows that curve, which is really cool. But I don't want to have this little sharp edge right here as it's being inserted into the pipe. So check this out. I'm going to click that edge, say chamfer, and we're going to do that distance and angle again. And it actually remembers your previous entries in here. So I could come in and say I want that to be 0.2, and it remembers that. I could come over here and it remembers all the different degrees that we did. So I'm going to say 75. And you can kind of see how it basically joins with this existing chamfer. So another neat little tip, if you just click those little down arrows, it remembers your previous entries. Okay, so I now have one of these. And I want it to go all the way around. So we'll say pattern, circular pattern. Sometimes by default it's set to faces. Please don't use faces unless absolutely necessary, because think about how many faces I'd have to select and I'd have to zoom in or whatever. Instead, I'm going to change it to features. I want to pattern the emboss feature, and I want to pattern that chamfer feature. So it's going to take this emboss and pattern it around. And it's going to take that little chamfer and pattern it around also. What's my axis? I could click on an edge. I could click on a face. It really doesn't matter, honestly. I'll say that. Let's do 8 of these. I'll say OK. And there is our foot. Literally looks like about maybe 10 features. I could have done this as a revolve. I mean, there's many different ways. I could have drawn and extruded down. I mean, there's many different ways you could create this. Okay. I'm going to change the appearance of it really quick just to make it a slightly different look and feel. So I'll just do this black textured plastic. And the last thing I want to do is put it where it belongs. So I'll say joint. In fact, so here's another little tip. I'm going to create a joint. I like to do the joint kind of at a higher level. So instead of having it show up under the foot, I might put the joint under the leg assembly. In fact, you'll notice there's these joints right here. So instead of having them kind of hidden in sub-assemblies, etc., I'm going to activate my leg assembly, create the joint. I'll say maybe that circular edge with that circular edge, and it will position that foot right where it needs to be. I'm going to go ahead and save. I'll call this live stream session 3. Okay. Again, I apologize. I've probably got maybe another 20 minutes worth of stuff to show. I will continue on our next live stream. So next Thursday will be a cam live stream that Angelo is doing. Look forward to that one. And then after that, I'm continuing the miter saw live stream series. So tune in for that. I appreciate. Let me check at my. Yep, it looks like no questions from Angelo. Thank you very much for helping me out. And I hope all of you have a wonderful rest of your day and have fun fusioning. Thank you.